My name's Tristan Amati. I'm a solutions architect at ClickHouse. I'm joined here by Kaushik. He joins us from PeerDB, and we're going to spend the rest of the evening really putting the spotlight on PeerDB specifically. I think we all have a lot of familiarity with what ClickHouse is. We've been talking about it throughout the course of the evening, but we're going to do a quick recap for those who are not familiar. Just talking a little bit about, what ClickHouse is, what it's good for as we lead into the rest of the remaining portion of the presentation. It is a open source column-oriented distributed OLAP database, as you can see here. Because of its columnar storage and data compression capabilities, it's really perfect for storing and querying large amounts of data very efficiently. It also offers real-time query processing and really high concurrency at scale. This is the kind of thing where other data warehouses tend to eventually. So it's great for aggregations. So if you're asking the kind of questions of your data like, show me the max CPU usage over the last hour, or show me the sum of dollars spent within a specific time range, or in the example that we were just watching in the last presentation, show me the average query time in milliseconds for X amount of time, for those who caught it. This is exactly where ClickHouse really shines. On the other hand, there are other places that you can store your data. And one of those, as an example, is Postgres. So while we're on this topic, let's see a show of hands. How many people here are familiar with Postgres? I should see lots of hands. Yeah, exactly. This is probably the slide we could skip, right? This is probably the one that we probably don't need to share. But while we're on it, again, it's an open source relational database management system, but it has specific characteristics that make it popular for enterprise use beyond just open source tinkering in the corner of a lab, right? ACID compliance, this is really critical for highly transactional data, and it provides a sort of guarantee. And to the next point, data integrity, right? Being able to have mechanisms in place that other systems don't have, like constraints and triggers and foreign keys. It has a rich ecosystem, right? Lots of third-party tools are available for this. So if you wanted to build PostGIS for geospatial analytics, if you wanted to integrate with other systems, this is the platform that allows you to do so. So I saw a lot of hands raised for Postgres. How many people have run into limitations or performance limitations or scalability issue? Okay, I'm seeing almost as many hands there as well. Would love to hear it if you want to share and make this interactive, but I won't put anyone on the spot. You're seeing a lot of hands being raised because we deal with this on a very, very regular basis, Jake and myself from the solutions architecture side here at ClickHouse. And, we get on calls and we hear people saying, Postgres was working really well year one or year two. And then we got to a point where at scale or with really high concurrency or based on really complex SQL queries, we were running into limits where query performance wasn't what it once was, or the kind of performance I was getting at scale, it's no longer performing like it did in the millions now that I'm in the billions, right? So this is something we run into very often. And ClickHouse really picks up where Postgres leaves off. While they're both quite different, there are different characteristics that give them both unique pros and cons. As you can see here, Postgres can potentially hit performance limitations with analytical workloads. And from a scalability perspective at high volumes, you may tend to identify some of those issues as well. Long story short, this can eventually lead to a growing operational complexity, right? As you start building additional capabilities around trying to manage some of those limitations. Whereas ClickHouse just kind of out of the box tends to work really well, and with a little bit of tuning can get you into that subsequent query performance that a lot of people need, especially for customer-facing applications where, hey, the name of my business, my brand is at the forefront of a website or a dashboard or an interface where an internal set of users, a customer base, consumers from an e-commerce perspective might be consuming from that brand, and they want to make sure that it's snappy, it's performant, and it has sort of the consistent expectation from a performance perspective. Really what we have identified is that these systems sort of marry together very well. And we're really excited to share that over the course of this past year, this July, ClickHouse announced the acquisition of PeerDB. PeerDB is really the fastest and most efficient, cost-efficient way to migrate data from Postgres to ClickHouse using CDC, Change Data Capture. We'll talk a little bit about what that means in a moment here. But what we're noticing is that we're providing a lot of value to users of either Postgres or ClickHouse, because we're finding that there are a lot of users out there who already use both technologies because they recognize complementary benefits of both systems. There's a reason to have a transactional system in place for transactional queries. There is a reason to have OLAP queries for the type of analytic queries that I described a moment ago as well. They're a good match together because Postgres is, like I said, a great transactional database system, and ClickHouse is the fastest analytical database. And as counterparts, we recognize that Postgres isn't going anywhere. Stack Overflow just this past year ranked them #1 as the top database for the second year in a row. So recognizing that they're being used this predominantly in the enterprise space, but knowing that enterprises are also identifying appropriate workloads for heavy aggregation and analytics, we saw an opportunity to sort of marry these systems together, which is where PeerDB comes into play. So change data capture, you heard me mention that a moment ago. It is the idea of being able to essentially have a continuous integration of two data systems, being able to maintain a constant sort of sync of data from source to destination. And historically, this has always been really difficult to manage. It's often very complex. You have a lot of different tools in place to be able to do this. One system moving the data, another system in place just to identify errors, and another system in place just to identify acknowledgement or guaranteed at least once delivery of that data. But PeerDB does this sort of out of the box. It's a very set it and forget it kind of approach, which is the reason we've partnered with them to build this sort of acquisition. PeerDB's approach towards CDC has always been not only extremely fast, but really preserving the reliability and correctness of the data that's being migrated. So it's incredibly important to take care of not overloading the source system where the data is coming from. So by this I mean you don't want to hammer that environment with additional overhead to negatively impact performance. The last thing people want is another agent or another bot or another script running on their database server. Same goes for your web server. Same goes for your other applications. But PeerDB does a really good job of doing this in a very, very efficient way. With that, I'm going to go ahead and hand it over to Kaushik. Kaushik is CTO of PeerDB, so we're really excited to have an opportunity to have him here today. So let's hear a round of applause for him.
Okay, hey everyone, I'm Kaushik. I was the CTO of PeerDB. Now I lead the data integrations team at ClickHouse. So a little bit of background about myself. Prior to PeerDB, I was working at Google. I was the tech lead for Flutter, mostly for iOS and Fuchsia, their own OS. And before that, I was working at Palantir on data systems. So my whole life I spent on either open source software or Postgres. And now I'm at ClickHouse trying to make it seamless to move data from Postgres to ClickHouse, right? So today I'll be diving into some of the optimizations that go into making PeerDB happen. And along with that, I'll be doing a live demo showing PeerDB in action as well. As most of you here know, right, like Postgres is typically at the center of your app stack in the sense that if Postgres goes down, your app crashes. And Postgres is sensitive in terms of replication. Particularly if you look at RDS, Supabase, or any real provider out there, logical replication is disabled by default. And it's for a reason, right? Logical replication is really tricky to handle, and doing it right requires a lot of expertise. So the first part of any replication job is the initial load. And initial load is typically hard for two reasons. We move a lot of data, and it's really expensive. So if you look at cloud egress costs for any ETL tool, they blow your bank. So it's really important to do it in a way where the load on the source database is really low, and also the cost is really low. To do this, we do something called as parallel snapshotting. So when you look at a table in Postgres, let's say it's a multi-terabyte table, right? And you want to copy it to ClickHouse consistently. To do this, you have to maintain a transactional snapshot open for the entire duration of your initial load, and then you have to start copying your data. And the challenges with copying your data are that your connection can drop at any moment, or you have a minor version upgrade on RDS and your database goes down, right? So you have to be really doing things in an idempotent way. And to do this, we partition the table into what's called as CTID partitions. And CTIDs are nothing but tuple identifiers to rows in Postgres on disk. So when you reference and seek to them in Postgres, you have very minimal I/O load. So when we break things into partitions based on CTIDs, we have two advantages. If one partition fails, we can retry that particular partition over again. And the second thing is the I/O load on your source database is really low. And the third thing is, like most of you here identified, loading data into ClickHouse, you can't really play it insert by insert. You have to kind of bulk copy it at once. So what we do is we convert the rows in Postgres into binary serialized format called Avro. It's like JSON. We also further compress it using ZSTD to reduce your cloud egress costs, and then bulk load them into ClickHouse. So with this, we can kind of avoid both the problems that I outlined before. And the next thing is, once the initial load is complete, right, we have to keep the databases in sync. The way to do this is using CDC or logical replication. In Postgres, the way change data capture works is through these things called replication slots. And replication slots are nothing but buffers that contain diff to each rows, right? And let's say we create a logical replication slot and the activity in your database keeps going. You keep getting these wall log entries, right? And when you, so what PeerDB does is we then establish a logical replication connection to your Postgres and start the decoder process, read these wall changes, and replay them onto ClickHouse. There are again the two same challenges that I talked about. I/O load on your source and fast throughputs on the destination. How do we achieve them? So each time we establish a logical replication connection, it's very intense. It's a very intense process on Postgres. It's called a logical decoder process. And we have to read the wall and seek to the position where you've acknowledged to. So we need to really keep this connection alive for the longest time. And we do that. And the second thing is, while we receive these changes, we can't directly replay them on on ClickHouse again, for the same reasons I've outlined before, right? So we, again, batch them, convert them to Avro, and then bulk load them, right? We micro batch them to keep the latency low as well. Building onto that, right? Another optimization that we're developing, especially to cater to workloads where there's long-running transactions on your Postgres database, right? So until logical replication v1, Postgres would only give you committed transactions. And the issue with that is when you have a long-running transaction, all the sub-transactions that it kind of spawns out create a lot of wall log entries. And if you wait for the commit to happen, you get this huge multi-gigabyte or tens of GBs of wall that you have to process, until which your Postgres database is kind of overloaded. To prevent this, Postgres has released a new version of logical replication called Logical Replication v2, which lets you consume in-flight transactions. But it's not as simple as that, because now the onus is on the ETL tool to maintain the transactional semantics. So your transaction can get rolled back, your sub-transaction can fail, and taking care of this is a really intricate process. PeerDB is also open source. We have a PR out for this. We're hoping that in the coming releases. So now coming to your day two operations, right? You have your logical replication up and running, everything's synced, your things are going fine. We have three key things that we have to kind of monitor and keep track of. The first thing is the replication slot lag or the growth. It's important to keep track of your replication slot growth, because finally the slot resides on your Postgres disk. And if you don't have enough disk provisioned, this can cost you DB downtime and your app downtime then as well. And the second thing is monitoring the number of active connections. Especially during initial load, given that we partition and load things by chunks, your Postgres has limited number of connections that it can kind of give out, 200 or 400 or whatever. So once these connections are consumed, your app goes down because it doesn't get new connections. So we keep track of that, and we also notify you to both email and Slack if things go wrong. Last but not least, proactive monitoring of Postgres activity and wait events. So pgstacked activity is really useful in the sense that it gives you the wait events for each Postgres action that's going on, but it's hard to keep running these queries and keep track of them. So we trend these, we also alert based on them so that you can proactively look at your source database to ensure that the load is appropriate. To sum things up, right, at PeerDB, we are able to do all of these because we are specially Postgres optimized, right? We don't have any other sources right now. We are hyper optimized on Postgres, and that enables us to deliver features like parallel snapshotting and continuous replication slot reading, right? And a lot of this progress is thanks to help from a lot of Postgres contributors and ClickHouse committers as well. We had the opportunity to partner with a lot of them. So with this, let's go into the demo. Give me 1 second while I figure out the screen situation. So I have a PeerDB instance kind of set up over here. It has a couple of peers or data sources that I created. One is PG, which is Postgres, and the other is ClickHouse. So I'll quickly go into Postgres, right? These are all the stats that I was talking about, where you can see PG stat activity live right here. You have replication slot informations here, and like things like that. Once we create the replication job, we can see it a little bit more. I have a table in Postgres called events. Let me see it. Yeah. If you query it, it has 1,006,000 rows or so. And let's quickly look at ClickHouse as well, right? There's no tables here, but I'll run this query to make it fail anyways. Yep, it fails as expected. So now let's try to replicate this events table from Postgres to ClickHouse. So we're going to be going with the CDC mirror like we've talked about. Let's call this demo. Please work, because demos have this tendency, right? Then ClickHouse demo Austin. And then we have a couple of parameters that we can configure here. There's a bunch of advanced settings that I won't go into now. The main thing is sync interval. It's in seconds, and how frequently you want your changes replicated from Postgres to ClickHouse. So let's make it 10 seconds for the sake of the demo. And I have public.events, which has 1,006,000 rows. Let's start replicating this. We have this validate option that will check. And it's valid. So now let's go ahead and create the mirror. So what this does in the background is it does a few things. First thing is we follow a model called ELT, where we also store the set of raw changes like a lot of you here do. And then we also have normalized tables set up on the destination, which is ClickHouse. On the source Postgres, we set up the replication slot. We validate that the user has all the right permissions to create the publications and get the events. We also create publications that are specifically tied to these tables because they're really performant and you don't want changes to other tables kind of flood your Postgres wall. So now that this mirror is created, let's go into it and see the initial copy. Yep, if you see this, it did it in 2 partitions and we moved over 1,006,000 rows. Let's validate this on ClickHouse. Me run this query again. Yep, as you see, hopefully it's visible. It's 1,006,000. All of them are replicated. Thank you. And let's, I think I have to refresh this. Let's look at a few rows in the table as well to make sure that the format is kind of matching up. Right, it does. So the last thing I want to do is I want to insert a few rows into this. I have a script, insert 1,000. Yeah, so it's basically just running this insert command with generate series. So now these inserts will be populated into the wall or replication slot of Postgres. PeerDB reads them, stages them to the raw table, and then normalizes them. We use replacing merge trees under the cover. We have a version identifier called PeerDB version that kind of determines the latest version of the row. And replacing merge tree takes care of the rest basically. So now let's look at PeerDB UI really quickly and the sync status, right? Yep, we have 1,000 rows synced, events table, all of them are inserts. Let's run the count query to kind of confirm this. Yep, seems to be working. Thanks all. I'll be giving it back to Tristan.
Yeah, that was awesome. Thanks, Kaushik. I've never seen an application be so seamless and easy when it comes to being able to migrate data and do so, honestly, within a visual UI, the interface that's very point and click in terms of its ability to be, honestly, just incredibly easy to use. So thank you for demonstrating that. That was really awesome. So there's really 2 main use cases that we see people using something like PeerDB for migration of and synchronization of Postgres data into ClickHouse. One is that one-time bulk load. This is really important if you have a really massive Postgres environment and you just need to get it over and you want it done in, honestly, the easiest way possible. There's no reason not to just use PeerDB. There are other mechanisms to do this. People have done it. But when an easier solution just exists, it's usually just the path of least resistance to get the job accomplished. The other use case that we see a lot of our customers using PeerDB for is not just a one-time load, but a continuous stream or a continuous sync of data from Postgres into ClickHouse. So this involves being able to mirror the data. You set it one time and you're able to forget it, and it just makes it as easy as it can get. I'm really happy to announce that to this date, since the July acquisition and partnership with PeerDB, we've moved several petabytes and petabytes of data thus far and growing. So it's something we're really excited about. We're going to continue to see this grow into other areas as well. So please stay tuned and keep informed as we make additional changes and improvements to that partnership. So thank you, Kaushik, and thank you all as well. Appreciate it.